Today I'd like to talk about database systems. What is a database? A database basically is an organized collection of structured information. When we use data, we store data in text files. Text files are suitable for small amount of data. However, using text file is not practical for large amounts of data. When there is large amount of data, typically we use a database management system, in short called DBMS, which is software used for large amount of data. Using a database, it is easy to store, retrieve, and manipulate data. Some typical examples of a database management system include MySQL, Access, Oracle, and also SQL Server. We use SQL, which is structured query language, for accessing and manipulating databases. There are two types of data in a database: the data itself as well as metadata. Metadata basically is a description of the characteristics of the data, the real data. The relational database model is the most common type today, in which data elements are stored in tables. In the relational model, entities are stored as two-dimensional tables. Records are stored as rows, and attributes or fields are stored as columns. Tables can be linked, meaning there are relationships between them. Relationships can be one-to-one, one-to-many, and many-to-many. Let's go over several terminologies. A database is a collection of interrelated tables. A table is a structure that stores data in rows and columns. A field basically is a piece of information. And finally, a record is a set of fields about a single item. For example, looking at a record in a database about a person, we may see a set of fields such as the ID, first name, middle name, last name, address, and etc. A record basically is a row in a table. In a database, each table has a key called primary key. Each row in the table is uniquely identified using the primary key. As an example, in the table, student ID is primary key, and it serves as an index to quickly retrieve the record. Columns in a table are also called fields or attributes, and each column has a data type, such as varchar, such as numeric, and etc. Now we talked about normalization. Normalization is important in reducing redundancy in data. As an example, in the student table, we can see majors such as computer science and chemical engineering repeat multiple times. If we store data this way, then there is redundant data, and it requires additional storage space. So normalization helps break one large table into several smaller tables. Instead of having a major column with repeating groups, now we use a major ID column. The major ID column refers to another table, namely the the major table. In the student table, each student is an entity, and similarly, each major is also an entity in the major table. Here we create a one-to-many relationship in which each student has one and only one major. On the reverse relation, each major has many students. The major ID in the major table is the primary key. And as we can remember, in the primary key, each key is unique. The major ID column in the student table is a foreign key. Each major ID in this column is not unique. When we look at a one-to-many relationship, we can see the primary key is on one table, and on the other table we can see the foreign key. The foreign key is just a field of the other table. The data in the foreign key field is not unique. Business rules in the organizations are used to define entities, attributes, relationships, and constraints. The data in the database reflects the business rules in the organization. Between entities in a database, there are three types of relationships. The type depends on the cardinalities of relationships. Basically, it is the number of instances of one entity associated with another entity. So from there, we have one-to-one relationship. As an example, each person may be associated with a spouse. An example for one-to-many relationship is when we have employee department relationships. Each department may have multiple employees. On the reverse relation, each employee belongs to one department. And finally, an example for many-to-many relationship is when we have student-course relationship. Each student may take many courses, and each course can be taken by many students. Relationships are set by placing primary key from one table as a foreign key in another table. On this slide, we have more examples. Employee and address. This is a one-to-one relationship. An employee has one and only one address. This constraint means only one. And on the reverse side, we can also see that each address is owned by one and only one employee. Now look at the next example. This is on one-to-many relationship. This constraint means 0 or more. So a customer may order 0 or more orders. On the reverse way, an order can be ordered by one and only one customer. In the last example, this is a many-to-many relationship. Instructor and students. Each instructor may teach one or more students. And each student may be taught by one or more instructors. This slide gives you more information on cardinality constraints. The first constraint means none or one. The second means none or many. The third means one and only one. And the last means one or many. We use entity relationship diagrams to represent or to show the relationships between entities. In the diagram, we can see that an instructor may teach one or more students. On the reverse direction, we can also see each student is taught by one or many instructors. Each student belongs to one department, and each department has one or many students. Now look at the other side. An instructor belongs to one department, and a department has one or many instructors. We use SQL, which stands for Structured Query Language, to manipulate data in a database. The main operations include insert, update, and delete. Insert is to insert a record to a table. Update is to update a record with new information, which can also be on multiple fields. And finally, delete is to delete a record. We will see more details when we practice with SQL statements.